Welcome everybody to my first proper live stream of an IGCSE Mathematics past paper. If you have any questions, please feel free to post your questions in the chat section. Right. Welcome everybody to... sorry for the audio problems. Just checking the live stream in the background. Okay, right, so if any questions pop up, please let me know and I'll gladly try and answer them while I'm busy doing the past paper. Today's past paper is, as you can see, the October-November 2021 from, basically that paper. It's IGCSE Maths and it's the first paper, so it's a paper 2. And it's only a 70 marker, so it should take you no more than an hour and 15 to an hour and 30 minutes. So what I want to do is just basically go through it from the front cover all the way through and answer the questions how I think would be best answered. And yeah, again, if you have any questions, please post it in the chat section. So firstly, we have the first question. The temperature at midnight is minus 8.5 degrees Celsius. The temperature at 11 a.m. is minus 1 degree Celsius. Work out the difference between temperature at midnight and the temperature at 11 a.m. So to calculate difference, all we need to do is a subtractive method, right? So we can see, okay, temperature has gone from minus 8.5, and we agree that it has obviously increased to minus 1. So we can just go minus 1 minus 8.5, and that gives us a difference of, let me get my calculator out here, joking, it is going to be 7.5 degrees Celsius. Okay, and so you just place 7.5 in the section below. Okay, then as we move through, we will get the rest of the answers. That's a whole lot of paper. Jeepers. Which one am I doing? Yeah, October, November, paper 22, not paper 21. I need to change that quickly on my stream. And okay, let's change that to paper 22, just so people aren't confused. Right. So back to the question paper at hand. Right, so that's done there. Then we've got a stem and leaf diagram. So this is relating to the stats chapter. And in our stats chapters, we learn how to order information using this abbreviated version, which is a stem and leaf diagram. So what we're going to do is look for the modal, median, and percentage of women who are older than 51 years. And we have 15 women here. Right, and just remember, whenever you are drawing a stem and leaf diagram, the key is absolutely vital. I think you get a mark for it, those of you doing AS stats, or even if you have to create your own stem and leaf diagram in IG. Right, anyway, so the modal age is the most common or the most reoccurring value. So we agree that 41 years appears twice, and that I would say is the modal age. So 41 years. The median age is the middlemost. So because we have 15 women, a good way to find the median is using n plus 1 over 2. And so all we need to do is take our total number of women, which is 15, add 1, divided by 2, and we get a value of 8. And this 8 isn't the value of the median, it's the position of the median. So we count from the bottom of our group and we move forward. So we go 1, 2, 3, 4, 5, 6, 7, 8. And we see that this point over here is our median value. Okay, so 43 is our median age. Now they say the percentage of women that are older than 51 years. So we look for 51, and we can see that it features in this space over here. So there are a total of 3 women who are older than 51. So we're going to go 3 over the total, which is 15, and we multiply that by 100%, and that will give us our percentage of women who are older than 51 years. So 3 over 15, which gives you a fifth, and that's going to be 20%. Right, next question. We have a time conversion. I believe this relates to chapter is it 17? No, chapter 13, which is all about measurement from your IG textbook. Right, so change 2.15 hours into minutes, or 2 hours 15 minutes into minutes. So how do we do that? I mean, unless this is decimal time, but I doubt it. I don't know why they would put that in there like that. We can check later when we go through it. But yeah, basically to convert hours into minutes, we are going to go 2 times by 60, and that gives us 120 minutes. And then the 0.15 hours, if this is decimal related time, which would be weird, then we agree that it's going to be 0.15 times by 60, and hopefully that gives us a nice value. 60 times 0.15, and I get 9 minutes from that. And so my total amount of time is 129 minutes. Now I'm just going to double check that, because they might be using decimal time, which is weird, because they do a point. I mean, if they had 2:15, then that would make sense. So we have a total of 129 minutes. So they were using decimal related time. Right, moving on. Again, for any of those who have joined the live stream, welcome. Please feel free to leave a comment for any questions that we've covered. And if you have any questions, please just leave a comment. That's pretty much it. Okay, so here we now have what looks like a trigonometry related style question. So we've got triangle ABC and triangle ACD are isosceles, meaning these lengths are the same. And then we have triangle DAB, which is 86 degrees, and the angle ADC is 58 degrees. So find the value of x. All right, so this is quite interesting. Now we know with isosceles triangles that the base angles are identical, and so we understand that this is 58 and this is 58 as well. All right, so if I'm going to be formal about my working out, which is a good idea, so angle ACD is equal to ADC, which is equal to 58 degrees. And now I can find out what this angle up here is, this CAD angle, by subtracting 58 times 2 from 180 degrees, because we understand that the total angle in a triangle, the total internal angle of a triangle is 180 degrees. So we go 180 minus 58 minus another 58, and that gives me a value of, I want to say 64. Don't want to make any mistakes here, so just use your calculator. Minus 58 again, and the answer is 64 degrees. Right, so because that's 64, we agree that this portion of the angle that is 86 degrees will be 86 minus 64. So BAC is equal to 86 minus 64, and that's going to give me a value of 22 degrees. That's quite an acute angle. Minus 64, yeah. Then lastly, we agree that these two angles are the same, so we subtract 22 from our total of 180, and then we divide by 2 to find the angle x. So 180 minus 22 divided by 2 gives us x, and we get a value of x being 79 degrees. Right, moving on. Oh, you guys can see my stream there. Right. Cool. Next question. Question 5. Angelique rents a room for a party. The cost of renting the room is $15.50 for the first hour and then $7.25 for each additional hour. She pays a total of $95.25. Work out the total number of hours she rented the room for. Okay, now my thinking here is we can try and relate this to an algebra sort of situation. Also, we should think about, okay, even if she doesn't spend a full hour there, she still has to pay for the hour. Okay. Right. So we understand the total amount. So what we're going to do first is subtract the first hour because that's a different value. Right? By removing the first hour, we can then divide by 7.25 or $7.25 to find the number of hours thereafter. So we subtract 1550 and that gives me 79.75. Just going to double check. 95.25 minus 15.50 and yeah, $79.75. Now we can do a division. So we agree that 1 hour has been done and now we can divide by that 7.25. So 79.75 over $7.25. And this should go in a decent number of times. 11 times. So the total number of hours is going to be 1 plus 11, which equals to 12. Right, moving on. These are classic questions. They typically ask one of these for every single IG exam. And basically they're trying to get you to think of BOD mass. I know around the world you guys typically use different values or names for this thing. Sometimes PEMDAS or BIDMAS or BEDMAS. Any of those are the same thing. What we need to understand is that division must occur first. Right. So we have 1/3 divided by 7 over 6 plus 1.5. Oh, sorry, 1 over 5. Now here we could obviously check with our calculator, but let's try and do it without a calculator because working is where you guys get your results or where you get your marks from. So first off, we need to sort out this division. Now I learned that we can do something called tipping and timesing. So if we have 1/3, we can multiply by the inverse of our fraction. Okay. And that is a lot more manageable and a lot easier to work with because we can cross cancel some values. So we agree that that leaves us with the 1, that leaves us with the 2. And now we basically have 2 over 7 plus a 5th. Okay, cross cancelling, because if we had to multiply these two fractions together, we would have 6 over 21. And then we would have to do a simplification step by dividing both the numerator and the denominator by 3, leaving us with 2 over 7 in any case. So by cross-cancelling, we're just doing some working before we actually do the multiplication step. And lastly, we need to add two fractions. Now, when adding, something very critical that we need to note, and that is common denominators. Common denom, okay? And in order to find common denominators, the easiest method is by just multiplying each denominator by each other. So in this case, 7 times 5 is 35, so we want 35s to be in the denominator of both. In some special cases, we don't necessarily need to do that. We just need to find the lowest common denominator. Yeah, and that's just doing the same as an LCM process or lowest common multiple, but we're looking at denominators only. So what I'm going to do is I'm going to rewrite it. So I'm going to say, cool, 2 over 7 times by 5 over 5. And when I multiply by any number over itself, I'm just timesing by 1, so I'm not changing the value of the fraction just the numbers that exist with it. And then this 1/5, I'm going to times by 7 over 7. Okay, because we agree anything over itself is 1. I'm not changing that fraction either. And I'm going to end up with 10 over 35. Okay, just noting that when I multiply fractions, I multiply numerators together and I multiply the denominators together. Okay, and same thing here. I'm going to get 7 over 35. And then lastly, I can combine because we now have common denominators. And my answer is 17 over 35. Okay, so quite an important basic sort of principles that we need to employ when solving these particular questions. I mean, it's 4 marks. I think this is the highest mark question we've had so far, and it's just doing fractions. So it's definitely a nice way to get a lot of marks, and it's not terribly difficult. You just need to make sure that you're following the rules of answering your, just answering questions in a very reliable manner. Okay, being consistent. Right, next question, question 7. Katie has 5 white flowers, X red flowers, and 2X plus 1 yellow flowers. She picks a flower at random. The probability that it is white is 1/12, and the probability that it is yellow is what we need to look for. So find the probability that the flower is yellow. Right, now this is quite a good piece of information because we know what the probability of a white flower will be. So that's going to basically lead us to finding some sort of total or finding out what X is. So once we find out what X is, then we can determine the probability. Right, now how do we calculate probability? I generally go with the idea of what we want over all possible outcomes. Okay, and this is a go-to formula. I mean, it's not really a formula because it's all wordy, but it's just the good go-to thought. Right now, in this particular case, we know the probability of the white flower is a 12th. And what we want is the total number of white flowers in the group. So we agree that's going to be 5. And then all possible outcomes, well, we agree that there's white flowers. And I think a lot of people forget about this in these sort of circumstances. But there's 5 white flowers, there's X red flowers, and there are 2X plus 1 yellow flowers. And now we basically have an algebra problem, which is not too bad. So we have 1/12, and that is equal to 5. Now we can't cancel the 5 and this 5 because, so we can't do that. That's not allowed. Okay, and the reason being is that our denominator has multiple terms. So we can't just remove any particular denominator because we feel like it, because it looks like cancellation. It needs to be multiplication occurring, because multiplication groups things together. It gives you one big super term. So we're going to have 5 plus x plus 2x plus 1, just getting rid of the brackets. I'm just going to continue my working out over here. We have 1/12 is equal to 5 over, that's going to give me a 6. We're just going to group like terms, so 5 plus 1 is 6, and x plus 2x is 3x. And this is where the fun happens, right? Let's try and get rid of fractions. I'm not a big fan of them. I generally tell all my students that what don't we like? We don't like fractions. And in order to get rid of the fractions, we're going to cross multiply to get rid of the denominators. So we're going to have the 6 plus 3x. You notice how I bracketed together. So I'm going to move those across. So it's going to be 6 plus 3x. And then here I'm going to have 5 times by this 12, which is 60. So 5 times 12. Again, because this is that 1 times by that whole denominator. So we're going to have 6 plus 3x is equal to 60. And now solving for x, numbers on one side, x is on the other. So I'm going to have 3x is equal to 60 minus 6. So 3x is equal to 54. And now I just divide both sides by 3. And 54 divided by 3 is that, what would that be? Is that 18? 54 divided by 3, 18. Oh, hold on, that's not the answer yet. I get x equals to 18. Right, and x represents the number of yellow flowers. Okay, well, 2x plus 1 equals the yellow flowers, and x equals to the red flowers. So we understand that red equals to 18 total. And for my yellows, I've written too big here. My yellows, I'm going to have 2 times 18 plus 1, which is 37 yellow flowers. And so my final probability that I'm going to have as a yellow flower will look something like this. So let's remove this, get some space. Okay, probability over yellow is equal to the number of yellow flowers, 37, over the total number of flowers, which is 5 plus 18 plus 37. And then we put that into our calculator, and we should get a simplified answer. Right, and my total is 37 over 60. Right, this doesn't simplify. And the nice thing about probabilities is that you can quote them as a fraction, as a decimal, or a percentage. I'm a big fan of writing probabilities as fractions, just because there's no rounding involved, it's an absolute value. Right, no questions yet. Cool, let's continue. Question 8. So this is an indices related question. You can just plug this straight into your calculator, there's nothing wrong with doing that. I could go through it entirely. I'm just going to do a little bit of work before we actually get to the calculator step. So we've got a quartic root, the fourth root, and this is a mixed fraction, and anything worse than a normal fraction is a mixed fraction. So to get a mixed fraction, we need to go 39 times 16, and that's going to be over 16, and then that will be plus 1. Right, and so what does that give me? 36 times 16 plus 1, that's 577 over 16, and that looks a little bit more pleasant to work with. So now we go the fourth root, and I'm just going to find that function, there it is, and it's going to be 577 over 16, and that is a horrific value. Wow. And that's why, because I made a mistake. It should be not 36, but 39. That makes a bit of a difference. 39 times 16 plus 1. And that's a much better value. That actually gives me a fourth root number. Whereas that 577 is absolutely disgusting. We get 625. And I know that 2 to the power of 4 is 16, and 5 to the power of 4 is 625. So this ends up giving me the result of 5 over 2, which is a lot more pleasant. Right, if you're doing this without a calculator, what you would first do is try and reduce these values to some sort of prime number or base number to the power of 4 to try and get rid of this fourth root. So basically what I said earlier, 2 to the power of 4, and this is 5 to the power of 4, and we're fourth rooting, and so the 4's basically all cancel out, leaving me with 5 over 2. Yeah, apologies for that little mistake. It tends to happen from time to time. Right, moving on. Question 9. Write these values in order of size, starting with the smallest. So ultimately what we need to do is just go through each of these values and determine which one is bigger than which. And I think the best way to do it is to put them all into the same format. So I'm going to write them as 4 decimal place values and then take it from there. So for instance, the very first one, we have 2.1 times 10 to the minus 1. which is the same as 0.21. Then I've got 0.2 reoccurring, so we can just write it like this. Okay, which we agree is bigger than this value. Right, next we've got 22%, which is 0.2200. And then we have the square root of 0.2, which I think is bigger than 0.2. Let's check. And I get a value of 0.4472. And then lastly, I've got 24 over 1,000, which is 0.0240. And now that definitely seems like the smallest value present. So I'm going to put that on the far left. Then I've got this 2.1. So the very first number on our list. So it's 2.1 times 10 to the minus 1. Next we have the percentage, 22%. Notice how I'm writing it in the same format that they've given, right? Because that's what they're asking us to do, to rearrange these particular values, not our rounded off numbers. Right, then we've got the reoccurring value, so 0.2 reoccurring, and then lastly we have the square root of 0.2. Right, next up, question 10. The interior angle of a regular polygon is 156 degrees. Work out the number of sides of this polygon. Now, typically with these questions, it's always good to do a little sketch. So I understand that that will be 156 degrees, and this is like a part of a much bigger polygon, as you can imagine, all of these angles being 156. Now, the easiest method, the less painful method, is actually determining what is my exterior angle. Okay, and the reason why I'm going for the exterior angle is because the sum of all exterior angles of a regular polygon meaning squares, dodecagons, decagon, heptagon, hexagon, all of those guys are regular polygons. If we just take our exterior angle and we go 360 divided by it, we'll find the number of sides. Okay, because the sum of all exterior angles of regular polygons adds up to 360 degrees. So angles on a straight line. So it's going to be 180 minus 56 degrees. And that leaves me with 24 degrees. And so therefore, the number of sides is equal to 360 divided by 24, which gives me a value of 360 divided by 24, 15. Right, and for those who are joining the stream, nice to see you. And if you have any questions, please feel free to put it in the chat room. Right, question 11. So we have a car that starts in its journey by accelerating from rest at a constant rate of 0.1 meters per second squared for 20 seconds. Now we can see that from the graph, they've given us that already, which is quite cool. Right, it then travels for 40 meters per second for a distance of 210 meters. So that's the constant speed section. And then the car decelerates at a constant rate of 1.4 meters per second squared before coming to a stop. Okay, so he's got to complete the graph. Now, constant speed is a horizontal line because we're looking at a speed time graph. And for how many seconds? Well, we don't know. But we know the distance. So I'm going to adjust that length shortly. So we understand that distance is equal to area of a speed time graph. So we understand that we have the area, but we need to determine the time. So it's going to be 210 divided by 14. That should give us the length of time that has occurred. So 210 divided by 14 is 15 seconds. So we take a look, we're going from 20 to 35. Okay, so I just need to basically manipulate this line right here. Okay, so that extends all the way to the 35 mark. And then they say the car decelerates at a constant rate of 1.4 meters per second squared before coming to a stop. So I'm going to assume that it goes all the way from there. And now we need to determine what time that occurs. So how fast is it stopping? So I'm just going to guess that it's that one, and then we're going to check with the calculation. Right. So how do we calculate time based off an acceleration? Well, we understand that acceleration is the gradient. Okay. And then we can also use just the standard formulae. Or you can even look at the triangle. All right. So the triangle says acceleration is equal to speed divided by time. So therefore, time is equal to speed divided by acceleration. Okay, then we can determine how much time elapses to get this particular change. So our speed is 14, we're dividing by 1.4, and our answer is 10. So we're going from 35 to 45, and that is the graph completed. Right, moving on. The table shows the first 5 terms of sequence A, B, and C. And they're saying complete the table to show the nth term of each sequence. Now I know quite a lot of people sometimes struggle with sequences, and there's nothing wrong with that. But what we need to do is try and do as much as you can. And if you're struggling, come back to this question at the end. Rather not waste too much time during the middle of your exam, and use that time at the end of the exam to go over questions that you weren't 100% sure with. So the first thing that I do with sequences, I try and look to see what is the difference between my terms. Like, is there something common that is happening to go from term to term? Right, so we agree that here we're subtracting 5, and I'm doing the same each time. So this is going to be a Tn is equal to minus 5n plus some constant value. Right. Now the cool way of determining this constant value is by going backwards, by adding 5. And that will always give me my when t is 0 sort of idea, or when n is 0. So 8 plus 5 gives me 13. So therefore my nth term is going to be minus 5n plus 13. Okay, so this is just a standard formula. This is your difference. This is the term position. If anyone struggles with this stuff, I'm happy to make a video on it. I should cover it in like 10 minutes. Okay, sequence B. So here it's a little bit more weird because we're dealing with fractions, and we can see that the numerators are increasing by 1, and my denominators are also increasing by 1, but they're offset by 1 value. Right, so a little bit weird. Now, a good sneak or trick to this is by dividing your starting term, if it's a whole number, by 1, because then we convert it into a fraction, and there we can see, plus 1 plus 1. Okay, but now we need to relate it to the actual position. Right, so to agree this is n equals to 1, n equals to 2, n equals to 3, and we can see that the n values relate perfectly with the denominators. So straight away I can see, okay, well my denominators are n, and my numerators are just 1 more than my n value, so n plus 1. Then sequence C is a little bit more interesting, because here it looks like we're multiplying by 2 each time. Right? Some would call this a geometric series, timesing by 2. Right? It's something that we learn about in AS maths a little bit more formally. Okay, but for IG, you guys need to just be able to identify patterns in general. So this is a times by 2 style pattern, where my starting term is a half. So how do we deal with that? Now another way of timesing by 2 is going 2 to the power of something, because we can see these are all base 2 values. I can rewrite this one as 2 to the minus 1, and if it's a single digit value, like 1, okay, if it's just 1, it's always be represented by any base to the power of 0. We learned this in chapter 2 with exponent laws. 2 to the 1, 2 to the 2, 2 to the 3, and so I can see that this is an exponential or geometric series. And I can see that I've shifted across 2 values. See, the third term relates to 2 to the 1, and the fourth term is 2 to the 2. So whatever my term position is, so for instance n equals to 3, it relates to what should be n equals to 1. I hope that I've explained that properly or well enough. But again, if you have any questions on that, just let me know. So here we're going to have 2 to the n minus 2, right? Because we've shifted the term that should be in the first position 2 to the left, or in this case 2 to the right. So for instance, 2 to the 1 occurs in the third term, not the first term. So we're subtracting 2 to get to the value we're looking for, because 1 minus 2 gives me minus 1, which is the exponent each time. 2 minus 2 gives me 0. And there we have our sequences in the nth terms. Moving on, question 13. We have write 243 times 27 to the power of 2n as a single power of 3 in terms of n. Now this is a straight up chapter 2 question. I can't stress enough how important chapter 2 is, so let's try and go through this particular one. Now whenever we're dealing with these type of questions and you want to try and combine exponents and that kind of stuff, they even give you a hint, powers of 3. So that is actually what your base value should be for your exponent. So can we write 243 to the power of something as a 3 to the power of something? So how do we determine that? Well, I can just continuously divide by 3. Yeah, that's probably the best route. Or I can just do trial and error. So I know that 3 cubed is equal to 27. 3 to the 4 is 81. And so 3 to the 5 is equal to 243. So understanding this, I can now write my equation as 3 to the 5 times by 3 to the power of 3 times by 2n, like that. It's a nice little trick there. Okay, so notice that the exponents are being multiplied. So I'm going to have, and now because we have multiplication with the same bases, I can add the exponents. So I'm going to have 3 to the power of 5 plus 6n. And that will be my final answer. 6n plus 5 or 5 plus 6n. Both are correct. Right, part B says k is equal to 2 times 3 squared times p cubed, where p is a prime number greater than 3. So we're thinking 5, 7, 11, 13. I doubt you will be R17 and above. Right. Right. 6k squared as a product of prime factors in terms of p. Very interesting. Right, now do you agree 6 can be represented as a product of primes of 2 times 3? So that means these 2 and 3 values will increase by 1, or the exponents will increase by 1 when you're multiplying. And k we know is 2 times 3 squared times p cubed. So k squared is equal to 2 squared times by 3 to the 4 times by p to the 6. Okay, if you weren't sure about what I just did there, all I'm doing is I'm raising everything to the power of 2, right? So when I write k squared is equal to all of this to the power of 2. And we know from chapter 2 that there's a distributive law of exponents. So each exponent here is going to multiply by 2. And so I'm going to get k squared is equal to 2 squared times by 3 to the 4 times by p to the 6. And now we can combine 6 and k squared together. So therefore 6k squared is equal to 2 times 3 times 2 squared times 3 to the 4 times by p to the 6. Okay, now the whole reason why they said p is a prime number greater than 3 just tells us that p will not actually combine with the 2 or the 3, okay, because those are the two lowest prime numbers possible. Okay, 1 isn't a prime number. They start from 2 onwards. So 6k squared is equal to, that's going to combine with the rest of the 2's and the 3's, so I'm going to get 2 cubed times by 3 to the 5 times p to the 6. And that will be my final answer. Okay, just a note, I mean, with Cambridge, etc., try and show as much working out as possible, right? Remember, you guys get marks based on the working that you do. So if at any point you just write down an answer and it's not a 1 marker, then just be careful, right? You might be losing out a lot of marks just in case you make a mistake. Having some methodology is really good because then there's something that the examiner can take a look at and mark accordingly. Or mark until you get something wrong. Right, question 14. We have circle geometry and we have P, Q, and R are points on a circle. ST is a tangent to the circle at R. Write down the value of X, give a geometrical reason for your answer. Right, now this is all chapter 19 related from the big math textbook that you guys should have. Now to determine X, we can see that ST is a tangent and I can see a triangle. Now whenever I see this, I like to think of a windsurfer. You can kind of imagine that there's like a windsurfer person over here busy catching a wave or something like that. And this is relating to something called the Tan Chord Theorem. And Tan Chord Theorem says that this angle over here, actually let's use this highlighter, this angle here and this angle here are equal to each other. So X is equal to 55 degrees because, what would be the legit name? I want to say the alternate angle theorem, but I'm just going to write tan chord for now. Okay, we'll check these answers at the end just to see if everything is correct. Right, another tangent from the point S touches the circle at V. Okay. From point S touches the circle at V. Right, so we've got point S over here, and we're having some tangent across. Okay. Give a geometrical, and this point over here is V. Give a geometrical reason why triangle SVR is isosceles. SVR. Well, there's a tangent rule that relates to this, because tangents, when they meet at a point, they are equal in length. Okay. It actually relates to a congruency idea, right? Because if we look at the centers, we know that tangents and radii are always perpendicular, and radii are obviously the same length, and there is a common side, the hypotenuse. And so by RHS, we agree that these triangles are congruent, and so therefore VS is equal to RS. Okay. That is discussed in chapter 13, or was it chapter, not 12, chapter 11? Yeah, it's chapter 11, if I remember correctly. Okay, the one about similarity. All right. As for the circle geometry rules, chapter 19, just make sure you go through those rules, learn the particular names. However, the main thing is identification. So by noticing, oh, this is a Tan Chord Theorem because I have a triangle and I have a tangent at the one vertex of the triangle. Right, next up, we have a straight line question. So we've got A as a point, 3, 16, and B as a point, 8, 31. Find the equation of the line that passes through A and B and give your answer in the form y equals mx plus c, which is your standard straight line form. Right, so to determine the equation of a line, we need two things, the gradient and c, which is your y-intercept. So how do we calculate gradient? Well, gradient is equal to your change in your y values over your change in your x values, and change is always represented as 0.2 minus 0.1, so y2 minus y1 over x2 minus x1. And then from here, we substitute in our y values and x values accordingly. So I'm going to make point B my point 2 and point A my point 1. So I'm going to have 31 minus 16 all over 8 minus 3. Okay, then we take our calculators out, and 31 minus 16 is 15. And we have 8 minus 3 is 5, so we should get an answer of 3 for our gradient. Now the next step is to determine your y-intercept. Now there are lots of methods here. I'm just going to show you using the form. So we have y is equal to 3x plus c, and all we need to do now is take one of these points and substitute it into this equation. All right, so I'm going to choose point A and I'm going to substitute it in. So I'm going to have 16 is equal to 3 times by 3 plus c. 16 is equal to 9 plus c, and so take the 9 over to the other side. 16 minus 9 is equal to c, and so therefore c is equal to 7. And so combining the gradient and the y-intercept, my equation for my straight line is y is equal to 3x plus 7. Right, the line CD has an equation y is equal to a half x minus 11. Find the gradients of the line perpendicular to the line CD. Now, this is all relating to chapter 10, quite an important one. And perpendicular gradients, we understand that the product of the two gradients must equal to minus 1. So here my gradient is a half, so 0.5 times by my other gradient must equal to minus 1. And so therefore my second gradient is minus 1 over a half, which equals to minus 2. And that's my answer. Right, and then on another note, if you're looking for parallel gradients, we understand that parallel gradients have the exact same gradients for the two lines. So if I wanted to find a parallel line for the line CD, I could write this, and I can have literally any other C value, and these two lines would be exactly parallel because they have the same gradient. Right, so I'm just going to erase that so no one gets confused. Right, moving on. Question 16. Sachin picks a number at random from the first three multiples of 3. He then picks a number at random from first three prime numbers. He adds the two numbers to find a score. Complete the table. Right, so the first three multiples are 3, so this is all just numbers. We agree that it's going to be 3, 6, and then 9. And then the first three prime numbers are 2, 3, 5. Right. And now all we're doing is combining values. So that should be 8. Yeah, that one should be 8 as well. So we're just adding all the values for the table. This should be 9, 11, 14, and this should be 12. Okay, just adding the two values together. Just want to double check. So he picks a number at random from the first three and then adds the two numbers to find a score. Cool, so we're just basically generating a table of all possible outcomes. Okay, and this generally leads to some sort of probability question, which is the second part. So given that the score is even, find the probability that one of the numbers he picks is a 9. Interesting. Okay, so given that the score is even, find the probability that one of the numbers he picks is a 9. Right, so what we're going to do is look for all the evens and then look at all of the even scores that relate to a score, a 9 being chosen. Okay. Now, where are all the evens? We got 8, 6, 8 again, 12, and 14. All right, so here are our scores. And do you agree that the number that he picks is this 9 here? Right, we're trying to find the probability of this 9 being picked. All right, so given that it's even, so we can ignore all the odd numbers. And which are the numbers that relate to a score or a value of 9 being chosen? Do you agree it's this one and this one? Only those two even values or even scores relate to a 9 being chosen or being picked at random. So therefore, we have 2 out of the 5 possible even numbers relating to a number being picked, which is 9. Okay. If you have any questions on this probability stuff, please leave a comment and I'll happily do a video on this particular idea. Right, moving on, we got some more advanced algebra. This looks like just simple FOIL, which is quite cool. So FOIL meaning we're going to expand by, oh actually, hang on, we're solving. So therefore we don't need to FOIL at all. We just need to factorize. But the cool thing is, this is already factorized. So in order to solve any quadratic, which is what this is, you need to factorize. Well, first make it equal to 0, then factorize, and then solve each factor for 0. All right, so that's exactly what we're going to do. 5x minus 3 must equal to 0, and 2x plus 7 must equal to 0. And then from here we can solve for our x values. So 5x is equal to 3, and x is equal to 3 over 5. The second factor is 2x is equal to minus 7, and so x is equal to minus 7 over 2. And we can write those values in here, minus 7 over 2, or you can even write them as decimal numbers, so 0.6, and that one is minus 3.5. Both are acceptable. Right, solving simultaneous equations. So here we have a quadratic and a linear function, or quadratic and a straight line. So what we need to do is try and solve these things together, trying to find points of intersection. That's typically what simultaneous equations relate to. And notice how we have 2 sets of answers here, and it's for 5 marks. So this is quite an important question. Now, the method that you should use is substitution, because we can see that both of these equations are in terms of x, with y being the subject. So I can now equate both of them together. So I can straight away say 2x minus 3 is equal to y, which happens to equal to x squared minus 9x plus 21. And like I said earlier, to solve quadratics, we've got to make them equal to 0. And it's a quadratic because it's got an x squared term as its largest powered value. So we're going to make this equal to 0 and take the 2x minus 3 to the other side. So I'm going to have x squared minus 9x minus 2x plus 21 plus 3. And then from here, I need to simplify. So I'm going to have x squared minus 11x, and then 21 plus 3 is 24. Now, this step is typically where a lot of people start to struggle, and that is the factorization step, and actually knowing whether or not we can factorize or we have to use the quadratic formula. Now, there's nothing wrong with brute forcing and just using the quadratic formula. That's absolutely fine. But sometimes it's a little bit faster to factorize and then get your answers based off the factors. So here what we need to do is look at our factors of 24. So we make a little factor table or factor list. And we agree that 1 and 24 is a factor pair, 2 and 12 is a factor pair, 3 and 8 is a factor pair, and 4 and 6 is a factor pair. Now, do any of these add up to 11? And the answer is yes, the 3 and the 8 do. And notice it's negative 11, so it's going to be minus 3, minus 8 will be the factors of positive 24. So I write down my brackets, x and an x, minus 8, minus 3, and so therefore I solve each bracket for 0, so x must equal to 8, or x must equal to 3. So now I've got my two x values. Now we're not done yet because we need to find our corresponding y values, and to do that we substitute into our equations. Now you can substitute into quadratic, but you agree that it's going to take a little bit more time. So substituting into the straight line formula will probably be a lot faster. So my first y value is when x is 3. So it's going to be 2 times by 3 minus 3, and that equals to 3. And then my second y value when x is equal to 8, I'm going to have 2 times by 8 minus 3, and that's going to give me 13. And there I've just solved simultaneously for the points of intersection of the straight line and quadratic or parabola. Right, moving on. Question 19, Venn diagrams. Oh, before I move on to the next question, if you guys have any comments or questions, please feel free to leave a comment in the comment section below. And if you struggle with factorization, let me know. I'm happy to do a video on that as well. Basically outlining how you can factorize more difficult quadratics. For instance, if they have a coefficient other than 1 for the x squared term, and yeah, just typically ones with multiple factors. I got a couple of tips and tricks for that, but ultimately you guys need to be good at your times tables to do your factorization proficiently. Anyway, question 19, Venn diagrams. So shade the given regions. Right, so here we have complement of A union complement of B. So what I like to do is first understand, okay, what does the complement mean? And we understand, or we know that the complement means everything outside of a particular set. And the complement of B is going to be this one, everything other than set B. And then union combines everything. So all we need to do is, even if it overlaps, we're combining it. We're adding every single shaded bit together. And notice how the intersection is actually being excluded. So all I need to do now is just shade in accordingly. So all of this shades in. Okay, and just try and shade as neatly as possible. I think the examiner will get the point. Right, next we have C union D in brackets, intersection not E or complement of E. So intersection, think overlap. Right, so let's look at what is C union D. C union D is this. Okay, the space of C and D spaces combined. Right, then we have complement of E. So that's everything outside of E's set. All right, so we highlight everything outside of the set E. Right, now that we've got that down, we're looking for the overlap. And can we notice that the region that's overlapping is where it's darker? So this space over here is the shaded region. Okay. Right. Functions. So find f of 6. So here there's two methods to find composite functions. Either we find out what the formula is first, or we go along by substituting in the value 6 into the first function f of x, which we know the output of that then is substituted back into f of x again. Right, so I think I'm going to do it that way because it's a little bit easier, especially considering that f is an exponential function. Right, so f of 6 is equal to 2 to the power of 6 minus 3, and that gives me a value of 8. And now this represents f of 6, so I'm going to substitute f of 6 into f itself. So ultimately I'm just looking for f of 8, which is 2 to the power of 8 minus 3, which is 2 to the power of 5. And if I remember correctly, that should be 32. Yeah, 32. Right, and then we have a very interesting question. Find the inverse of g of x plus 1. So we have a composite function with a function and its inverse. Now, due to the nature of inverses, if you work with the composite function and its inverse together, they actually cancel each other out. So the inverse with the original function inserted into it gives you 1, always. So in this particular case, we end up with 21. X plus 21 as our answer here. Right, so yeah, whatever the input actually is. In fact, is it 1 or is it x? It's just x. Yeah. Whatever your input is what your output will be for these things. Because when you substitute your value into your first function, it transforms it into an output, and then that output is fed into the inverse, which gives you your original input. So therefore x plus 1 is your input value. If you guys would like any help with functions, let me know and I can do some composite function videos. Find x when f of x is equal to h of 84. So here we need to find out h of 84 first, and then we can equate f of x for that. So h of 84 is equal to 5 over 84 minus 4, and that gives me a value of 5 over 80, and 5 divided by 80 is equal to a 16th. Right, and so we now have an exponential equation. We have f of x, it must be equal to 1 over 16, and so therefore 2 to the x minus 3 must equal to 1 over 16. Now, like with the previous question that we saw, to solve exponential equations, we need to have common bases, because I think we had a simplification question. Here is an equation. So let's try and get 1 over 16 to be 2 to the power of something, right? And the reason why I'm choosing 2 is because this base value is a good hint, an indicator as to what this term's base should be. Right, and we know that 16 is 2 to the power of 3. No, 2 to the power of 4. Yeah, 2 to the power of 4. And so 1/16 is 2 to the power of minus 4. Okay, if you're not sure about that one, look over your exponential rules, because we understand that x to the minus n is the same as 1 over x to the positive n. Okay, that's what I'm using here. Right, now that I got the same bases, because this is an equation, the exponents have to be equal as well, because I have the same bases. And so I can then write x minus 3 must equal to minus 4, and so x must equal to minus 1. There's my final answer. Right, question 21. I feel like we're almost there, almost finished with the paper. Expand and simplify. Now, first things first, let's deal with the square. Okay, please, please, please do not say that x minus 3 squared is equal to x squared plus 9. That is like mathematical sacrilege. It is so wrong. We can't do that, right? What we need to do is write down the bracket twice, and understanding that we actually have a squared binomial, and so therefore FOIL is required. So we're actually going to have x squared minus 3x plus 9, simplifying to x squared minus 6x plus 9. Okay, not this. That is just nonsense. Right, now that we've got the quadratic, we can now multiply that with the exterior binomial 2x plus 5. And when we're doing this, we do a FOIL type process where every term must multiply by every term in the other bracket. Okay, and so all of these must multiply by the 2x and the 5 respectively. And so we should have 6 terms that come out of this multiplication. So I'm going to have 2x cubed minus 12x squared plus 18x plus 5x squared minus 30x and then plus 45. Right, so that's just from all these terms being multiplied. And all we need to do now is simplify. And simplify meaning grouping like terms. So there's only 2x cubed. There's no other x cubed terms. We have a minus 12x and a 5x squared. Sorry, minus 12x squared plus a 5x squared, which gives me minus 7x squared. We have an 18x and a minus 30x, which leaves me with minus 12x. And only one constant term plus 45. And so that's what I write. Right, question 22. Solve the equation 7 sine x plus 2 is equal to 0. And they've given us a domain, right, where x must be between 0 and 360 degrees. Sometimes they talk about this as restrictions to your trig functions. But yeah, that's a domain for inputs for this trig function. So what we need to do is get the trig function as the subject of the formula. So 7 sine x must equal to minus 2. And then here I'm going to divide both sides by 7 to get sine x is equal to minus 2 over 7. Right, now from here, I need to use the inverse trig function, like sine to the minus 1. You can also call it arc sine. So x is equal to sine minus 1 of minus 2 over 7. And we should get an x value of sine minus 1, 2 over 7, but negative. And I get, make sure your calculator is in degrees, not radians. So I'm going to have minus 16.6 degrees. Okay, note Cambridge wants you to quote angular measures to 1 decimal place. Now, is this an answer? And you should all be saying, no, it's not an answer, because our domain says x needs to be positive and it must be between 0 and 360. So what we can do is we understand that sine is a cyclical function, meaning it repeats, and it repeats every 360 degrees. So therefore my actual x answer, my first x solution, is going to be minus 16.6 plus 360, and that gives me a value of 343.4 degrees. Okay, and that is my first solution. Now, are there any other solutions to this? Well, what we can do is use an alternative solution for sine, and that's based on a very particular rule. It's a rotation symmetry rule. So we know that sine of x minus 180, sorry, actually not that way, but 180 minus x is also equal to sine x. Okay, that's saying that if I go 180 minus my obtained x value, and we can use either one of these. So for instance, this minus 16.6, I'll get a second solution for x. And so therefore x2 is equal to, so go 180 and minus minus means a plus, 16.6, and I get 196.6 degrees. And there I have two solutions for sine. Okay, this is in chapter 15 in the curve graphs, or not the curve graphs, but the trig graph section, which has been, I think, yeah, this is added to this current syllabus that we're on. It wasn't in the previous syllabus, if I remember correctly. Right. Question 23, and I think this is our last question for the paper. Simplify. Now this one's quite an interesting one because we need to do quite a lot of simplification, and it's 4 marks. So first things first, let's take a look at the denominator. Right, the denominator is making me think of dots, or difference of 2 squares. All right, dots for short. However, I've got 2, and 2 isn't a square number. So what I'm going to do is factorize out 2. So I have just an x squared, because x squared is a squared number, or a square term. 5x minus 60, and that's all over 2 times by x squared minus, and then 288 divided by 2 is 144, which happens to be a square number, right? It's 12 squared. So I can automatically use difference of 2 squares for my denominator. So I'm going to have 3xy plus 36y minus 5x minus 60. And that's going to be all over 2 times by x plus 12, x minus 12. Okay, and that's just the difference of 2 squares rule. So if you want a rule, it's going to be x squared minus a squared is the same as x plus a, x minus a, factorized. All right, now we need to deal with the numerator. Now when I see 4 terms like this, and they all kind of have some similarities between them. So for instance, I see there's 2 terms with y, 2 terms with x, 60 is a multiple of 5, you know, something along those lines. 3 is a multiple, or 36 is a multiple of 3. So I'm going to use a grouping method for my numerator to try and see if I can factorize it further. So I'm going to combine these 2 terms and these 2 terms. Okay, and by combining them, hopefully I'll get a nice pair of brackets, and hopefully those 2 factorized terms will have common factors. So what's common between 3xy and 36y? And the 3y is a common factor for both, leaving me with an x plus 12. And then here, I can take out a common factor of minus 5, and that leaves me with an x plus 12 in the numerator. And here we can see the solution straight in front of our eyes. This x plus 12 is a common factor for both of these terms in the numerator. And so I can now write down my newly factorized value, which is going to be 3y. Oh, actually, I can now factorize out the x plus 12 from both of these terms. And that leaves me with 3y minus 5 in the numerator. and I have 2 times x plus 12 times by x minus 1. Right, now a lot of people will probably leave it at this point, but then you only get 3 marks. And that is because we actually have another factor pair that is the same in the numerator and the denominator, so we should actually simplify by cancelling those out. And so I'm left with 3y minus 5 over 2 times x minus 1. Now, in this particular question, they say simplify, and I feel that the most simplified form is something that is most expanded. So 3y minus 5 over 2x minus 2 is my final answer. But I feel that they will accept either one of these because you have done most of the hard work already. Right, and there we have completed the entire past paper. So I just want to say thank you if you managed to watch this live stream. If you have any questions, again, please feel free to leave a comment at any section of this past paper, and I'll try and answer them as soon as possible. If you would like me to do a video on any bits of these comments, on your comments, or on any of these sections in the question paper, and yeah, if you have a particular chapter in mind that you like really weak on, or something that you want revision, or any questions on particular chapters, feel free to leave a comment relating to the question, and then I can maybe either answer it via the comment or create another video separately. Just as a goal, I would like to try and do these past papers maybe once a week. If there are any past papers that you guys would like me to do that you've maybe struggled with and I'm not like 100% sure on, feel free to comment the past paper number, and then I can maybe go through that particular one in my future videos. Cool. Thank you so much for watching, and good luck for your externals. Bye.